So welcome everyone. Welcome to Plowing Postgres. First of all, before the beginning of the talk, I have two questions for you. So, who thinks you should never put your business logic in a database? So no one is raising hands, so I assume it's okay. And who thinks SQL doesn't compose? Okay, this is the two questions we're going to answer today. But first, we'll dive into a bit of a history because I like to introduce the tool I use. So what is Postgres? So we are back to 1970. There is some guy which is called EF Code. You might know already him. He's the guy who invented the relational algebra. And following its work at the IBM Research Laboratory, they beginning to program a system, a project to do relational algebra using data, which was called System R, which later became IBM DB2, if you have heard of it. And because the research lab was in San Jose in California and Berkeley was not that far away, some group of scientists at UC Berkeley began a project to implement also this relational algebra in a database they called Ingress. And side effect of this, they wrote a query language to manipulate set algebra, and this language was called Quell. So we're back to IBM, and the guy who wrote the system in IBM. So those two systems are quite coupled in terms of history. They needed a query language, but they didn't want it to use Quell. They wanted to use something better. They needed to do something better, so they made a SQL. And that's why SQL is called SQL, by the way. And also another funny fact about SQL is like at the beginning the acronym was SEQUEL, and actually it was already trademarked. So they got to find another trademark, so they removed the vowels, and we got SQL. But it's just like a trick to being able to have their language trademarked. And by the way, there is some girls also at a company called Relational Incorporated, I think. They also began to make a database, a private one, and this company just became Oracle afterwards. So the history of like relational databases is very, very, very intertangled. So the Ingress project finished, and a scientist at UC Berkeley also, which is called Michael Stonebreaker. So who knows Michael Stonebreaker? Yeah, I know Olivier. Okay, but yeah, and they begin to make a sequel to Ingress. So they called it Postgres, and their query language was PostgreSQL actually. And their logo it was not an elephant actually, it was a turtle. And fun fact is, like in Japan, the Postgres logo linked to historical events when Postgres was open sourced, it's still a turtle. So the logo of Postgres is not the same in the whole world. So I begin the presentation with a lot of fun facts about Postgres, but don't worry, we'll get to see some more interesting stuff later. And finally, in 1996, we got the Postgres project as we know it. And they implemented SQL and not Quell, and so we got a PostgreSQL. That's it. So I wanted to do this presentation to present you how we use it and all use cases. So I work at Ledger. It's a hardware company, by the way, but we have a lot of backends, and basically we are indexing blockchain data to have better results and to answer better queries about it. And this is what I manage at Ledger. I manage indexing and transactional services. So, long story short, we got some old system which was using Cassandra because it was the trend at the time. There are big clusters, like three data centers with 8 Cassandra machines, with a process that is analogous to ETL. So it was a lot of logic was in the Scala code, actually, and not a lot in the database, because Cassandra is a dumb database. It's not like personal. It's not very complex, what you can do with it. And we managed to migrate it to half the machine using Postgres. And we use more of a process. It's out of scope for this presentation, which is called ELT. So you extract, you load into Postgres, and then you transform it. And so you can use SQL to manipulate data, which is a good fit for it. And our motto for this project was to commit fully to Postgres, to make SQL a first-class citizen, to use it to manipulate data as much as we can, and to use all the features that SQL has to offer, because a lot of training, formation, and so on SQL focus on early SQL, like up to I know 1996 or something like this, and they don't introduce newer feature, and we'll see some cool feature in this presentation. And by the way, we are all doing it on premise, but with modern tooling, so we got to use an on-prem kube cluster, so it's possible. It's just that we need to know the tool you use. So if you don't delegate to a cloud company, you got to know it. And scaling vertically is very, very, very much viable. Like the use case, Google, on Facebook, on all the companies that use horizontal scaling, is very niche, actually. And most of companies, you can just buy better machines, and it's wonderful. For instance, we got a lot of machine on OVH, and obviously, and this is what you can have for less than 800 euro per month, which is pretty hefty, and which should handle all your need for like the first year of your company. And if you can exceed this machine, that means you have a good problem to solve anyway. So that's it. And by the way, we use a bigger machine for production. Everything is possible. So, what is working with first-class SQL? So what we do here is like we try to use SQL as a language, so to add a lot of tooling and processes to make it scalable. Because a lot of services that I used in my experience don't use a lot of SQL. They wrap SQL as early as possible with very simple queries, and they compose then services between each other. And what we do at Ledger actually is to the totally inverse thing. Like we delegate a lot to SQL. So first, if you're gonna be serious with SQL, you got to have migration. You got to get your SQL code in your code base. So basically, we use Flyway. There is many tools in the market. But actually, we use Flyway for migration. Then we use Postgres schemas, so namespacing for version of tables. There is a lot of tricks using namespaces. I won't get into a lot of details voluntarily on this presentation, but you can version your schema and be clear about what version of the schema you use, and use views and transactions to make it clear. You need to schedule regular baselines also, because it's much more readable to have one big file that describes or create tables, for instance, and not having a lot of like 30 or 40 migrations that are one-liners. So maybe something that is very interesting is like you can concatenate all your migration file, and you get a much better picture than having it separated in your code base. And there is a debate about migration. Either you're gonna go full independency or no independency. I mean, can your migration migrate twice and still get the same schema? I think it's a very bad idea, actually. And that you should never use create if exist, unless it is a very, very, very narrow use case. You got to do it. And yes, basically, you don't need it. Be confident. You don't need it. If the migration is not applied, it's not committed, and yeah. Okay, so once you have a schema, it's not enough. We need a lot of documentation. Today, it's documenting the code is a very big part of our job, actually. Either thinking about good names, thinking about architecture, and so on. So use it for SQL also. In your migration, you can comment in SQL with --, actually. You will see in the presentation. you can use the database actually to store comments. And there is in Postgres, you have the comment on any object, basically, is a string, and it will appear in tooling, in your IDE, in /d using anti/d using PostgreSQL. It's wonderful. Actually, you can store your comment in your database. I think it's wonderful, and it's also versioned into your schema, and you can add some like a lot of SQL wizardry. Is wizardry because it's not explained. Why does this guy make this query like this? So just use it. And then you go to test it, because we're going to write a lot of SQL. It's going to be first class with complicated query. But actually, you can test it a lot with your host programming language. Basically, test container is a no-brainer. I don't know who didn't know a test container, but if you don't know it for testing databases, go for it, because it allows you to never use SQLite, H2 Derby, all these embedded databases again, because you're going to use the core Postgres. It can also allow you to test new version of Postgres on your old code and validate migration and so on. And by the way, whatever is, if you take the SQL library you are going to use, they have a lot of modules helping for tests. For instance, Doobie has Doobie test. I won't show Doobie test, but actually you can check your queries against a live database, so you can factor a bit the thing between test container fixtures and having Doobie queries running, and so you can check every query you have in terms of encoder, decoding, encoding, decoding, and so on. In terms of just compatibility between JVM types and Postgres types, which are not 1-1. And you have Skunk also, and Skunk has a very nice feature that the error messages are the best error messages I've ever seen in my life. Come on, look at this. This is a good error message, telling you what happened, how to solve it, where is the error. And this is what you can have. So you just have to run your queries in your test. You just have a test like this query must pass without throwing, and you get this nice feedback if you have any mappings and so on. By the way, I'm not taking any points in what library you should use. Just it needs to support like inline SQL, because we're gonna write some SQL. And by the way, this is a very good usage of JSONB in our ELT process. Like we load a JSON and then we extract real data from this JSON to get the thing running. And then so insert is fast because you insert a batch of JSON lines, and the processing is very fast because you're only using the database against itself. And that's it. So when you are doing first-class SQL programming, I won't recommend having Quill or Slick or any type of code generation libraries, because you're going to use a lot of features of SQL, and SQL is made to be written and read also. And wrapping it to a Scala DSL doesn't defeat the purpose of what we are doing. We're going to try to quite never use fragment composition, because this is a plague for query performance, because you're gonna, if you, since we are functional programmer, we love equational reasoning, so we love to, I can factor this out, this subquery, it became a fragment, and then suddenly it's not a big subquery you manipulate, it's just a reference, a variable, and so you can use everywhere. So should you use everywhere? I think not. But we're gonna see a lot of ways to compose and to delegate and achieving the same conciseness without using fragment composition. And also, strict formatting helps. So, but I know it's very tricky, because when you're going to use SQL queries, which are strings, into an interpolator, into a Scala code, it's hard to have the interpolated string having a different formatters than the host language. It's possible with, I think, my colleague Raphaël Lemaitre, if you that should be have presented in this conference. Okay. Just did it, so it's possible. It's not easy, but it's possible. And yeah, you will see we use a very opinionated formatting for SQL. You like it or you like it not. What matters is like when whatever your team agrees on. So let's do it. And also a very important thing is like we gotta get out of the what I call the repository pattern. It's like you have, by the way, it's a modelization of RBAC, so role-based authentication. You have a user, you have roles, you have permissions. So user have roles, roles have permission, and so you need to authenticate people using this. And very naively, you will get this structure with a user repository, role repository, permission repository, and you get insert, update, get, and then you can compose these IOs on these methods to get what you want. And then you have more use case arriving, like things that are tackling end-end relationships. And this does not fit into the object model. Object model is made to have one relationship, one end relationship, end relationship doesn't fit well. You need to choose, either you add a role on a permission on a role. It's not clear enough, it's not satisfactory for me. So what I advise is better use some principle for CQRS. So we are not doing CQRS by the book with event sourcing and so on, but you segregate what is writing your queries and what is reading your queries. And often it's a separation you need, because the write path is often not the same workflow as the read path. And you can still compose this together because you can do transaction using this. And more importantly, since you're not anymore in a CRUD repository pattern, you can factorize your code. For instance, you can use these queries, which is more proper to your use case. Like, I want to add a bunch of user and roles, and that everything that database just merge it with the current database. I don't need to see what happened. I don't need to check my case by myself. Just insert all the user with this role or with permission and so on and so on. So it's more about, this is a toy use case, I know, but the important thing is more about having queries tackling real use case, and to have to push away the frontier of what is handled by the database and what is handled by the code. So you can see that it's a bit like putting business logic in the database, but just by better separating things. And by the way, once you have queries, you need to iterate and optimize it, and having some feedback on how they are performing, because yes, you are writing SQL. SQL is a very particular programming language because you're gonna have execution plans. You don't have control on the algorithm you use. It's the database that chooses it for you, but you have some levers to influence it. So better be prepared. So usually we use a dedicated editor for SQL, like the Beaver data group module in IDE, or as I like, raw PSQL, because it's an awesome editor. By the way, you can edit files and so on in PSQL. There is a lot of tooling to do. And by the way, you can have a much better explanation on your queries using all the options in Explain. It will be like bigger to read, but don't worry, I got you covered. There is a very nice website called explain.dalibo.com, and this thing is a very is a godsend when you want to I don't manage to do two things at the same time. Come on. No, it's how do I click a link on a Mac? So it's not my computer, by the way. But anyway, if you can help me. But anyway, this website, what it does, it's like it allows you to take the execution plan, you copy it, you paste it, and you get a very nice graphical representation. Yes. So this is one of the query we use, by the way. The execution plan, you can get it in the row tab. Sorry. No, it's okay. I will manage from this. You can get it in the row tab, so it's not a simple execution plan. You can see it. Anyway, full screen. F11? No. Go ahead. Okay, it's this thing, you cannot read it. It's not human readable, but on this representation, you can inspect it quite nicely. The bolder the links, the more row flow into your system, and you can using this, debug very big SQL queries. You have the time also. If you get all the options, as I told you, you get what buffer get hit by the query. If it does I/O, if you have there is bad estimates in terms of number of rows. If you have bad estimates all the way, it's maybe the time to do analyze on your table and wonderfully reduce your correct time by 100. Yeah. But yes, and it's pretty big query. You can see you have a CTE, which is used 3 times actually, and you can rejoin the query also. Yes, please. Okay, so go ahead, try it. Very nice tooling, and it allows us to scale our SQL actually, because we can debug big queries. And then don't forget maintenance. I know the auto vacuum is enabled by default, but you can tune it. There is a lot of options, like depending on your read versus write ratio, you want to optimize it. I won't explain the whole vacuum documentation page. It will be pointless. But go ahead, go see the vacuum page of the Postgres documentations. You can tune it to your case. If you're interested into having no vacuum at all, there is one extension which is called OriolDB. At the time being, it's pretty, it's a bit mature, but it's pretty non-practical to use because you have to patch your Postgres instance and then install the extension. But I think most of the patches are already merged, and there is some that will be in Postgres 18, and afterwards we could just use it. But it's a storage engine that doesn't use vacuum. So if you have vacuum issue, you have a solution. Analyze is also run by the auto vacuum process, but don't forget when you have big migration of data, like transferring one table from one instance to another, analyze afterwards, because if you don't do it, query will be very bad. And then there is a third thing to do, which is very not known, a very niche use case, but very not known. As you may know, Postgres, when you insert data, it will create new pages and just append to these pages. So data layout on the disk is in the insertion order, which is not often the order you want to request data. If you want to order all your pages by, I don't know, one query index, you can do it using cluster. And actually, it will do a big I/O operation by rewriting all the pages in the order of the index you want to use. And so when you are scanning the index, when you are doing run queries, you are just pulling everything from the disk in a much less page fetch than the original order. So you may, if you are accustomed to Cassandra or NoSQL databases where you have a key value store and then you are ordered by key and you can scan very fast, it's the answer to Postgres answer to this. You can order rows in a cluster in a Postgres table. So I want to tackle this thing, which is SQL is a functional language. And that's why we love it using as a Scala user, because, by the way, that's why I love it as a Scala user, because it's very nice to use in this functional property. So first of all, what is a functional programming language? I won't get into the whole debate because I know it's very touchy. But actually, for me, it's using pure function as much as possible. We cannot be pure all the way because there is I/O to do. Even in a database, you cannot not do I/O. Let's get. And what is a pure function? Is a function which is well defined on its input domain and output domain, and which is deterministic. So obviously there is part of SQL that are not deterministic. Like if you ask to have no is like is not deterministic. Or if you want to generate a new UUID, it won't be deterministic. But let's be as deterministic as possible. So we can split SQL in many sub-languages. The two mains are like DQL, which is just select actually, data query language, retrieving data for the database, and you have DDL, which is data description language, and all the insert, update, delete. So you segregate what read the database, what write to the database. And once you do it, you can see it as a function exists. So DQL, you have some data that arrives to your program, and DDL, you have some data and you do effects. And actually, it's not that true, because as you may know, Postgres is like an ACID databases. So you have transactionability. And so what you are doing is always a consequence of being in a transaction. So if you write it with a transaction in mind, you get this thing. So your transaction gets you a state of the database, and then you have a state of the database, read data. And this thing, and then when you are writing data, you have a transaction, you get a database state, then you have a function that takes data and write to the database. And actually, you will see, I have an example just afterwards, we can manipulate how a transaction is going to is flowing. So you can manipulate some sort of state encoding in a functional way using Postgres. So in terms of when you consider running the query, then yes, you are doing effects, you are getting data, you are putting data in the database. When you are in a transaction, things are much more functional oriented. For instance, here. Maybe you know it, maybe you don't know it, but you can do save points in a transaction. So you can save state at a point of the database and then roll back to this state. So you can have a dialogue between your code and the current transaction and really roll back to the point you want to roll back. And for me, actually, what I said a lot of things I won't, but you can disagree, and we'd like to discuss if you want. But for me, this is an accounting of the state pattern using SQL, by the way. But best to minimize this thing. One query per query. Try to achieve the most using one query is a bit of the leitmotif of this presentation. And then you need to have well-defined function. To have and to have well-defined function, you need to constrain it as much as you can. From my previous talk, you see that I love constraints. so we'll see how to do it and how to push it to the maximum using SQL. You need to avoid abusable data type, for instance, JSON and arrays in tables. So JSON and arrays are very a good use case when you want to retrieve data, want to aggregate things. It's very useful. But when you are storing things, except if you have a very niche use case, like arbitrary data some user can put and so on, it's not that well behaved. And then you need to index it, and it became a mess. And third point is to build tool. I mean, relational databases, they exist for like 50, 60 years, and they are made to do joins. It's one of the most optimized things in Postgres is doing joins. It's complicated queries, but in terms of performance, building small tables, very narrow table with not a lot of columns but a lot of lines, and then you join them together, it tends to be, from my experience, a better way to achieve conciseness and have a good schema that scales. So well defined. Let's check as much as we can to enforce constraints on your data. So you have the check constraints, which can arbitrarily check against an immutable constraints. Like you cannot check versus now or versus non-deterministic function. That's why I feel this functional programming vibes when I write SQL. It's like when you define a check on constraints, it needs to be deterministic. It needs to be immutable. Check can span multiple columns, by the way. You can check a column after at the table level and not at the column definition level. If you want to check not null, that something is not null, use not null. I think it's one of the most well-known constraints, but actually it's way faster than check A is not null. And because it's you have inlines and dedicated code path in Postgres to handle not null. And then a wonderful thing, which is you can create domains, so you can factor your constraints. If you are sick of having, like, for instance, you have an age in your database, you have many tables that use age, let's define it one way, put it into your migration, and never think about it again, because now you can declare a column which is of type age. And this goes for a lot of things. And the more if you want encode custom data types, you can do it using this. And by the way, this is much more powerful than the type system you have in Scala because you can check like arbitrary predicates and have to very narrow your type to what you want. So we covered checks. Then let's talk about consistency and how you can enforce consistency between tables. So first, you have unique index or unique constraints. You can just add unique to your column definition. You can also span many columns and have group of columns that must be unique in a table. And also it creates an index because it needs the index to check the constraints, and you get it for free. And yes, I won't get into much. I think it's very useful when you have generated IDs, but you have a natural key you want to enforce also. I don't know. The simpler thing is like you have an external ID from an external system and you need to couple it to your internal ID, so you get a unique column and you get fast query from the external ID, which is often what you want, and still primary key enforced using Postgres. Okay, also you have foreign key. I think everyone also knows foreign constraints. What I wanted to stress is just like it does not create an index. So it can trick you into, this is efficient because I have like a foreign key relationship, but it's not at all. You need to create it afterwards. And it's often a good idea also when you want to work with data. And they also can span multiple columns. So if you have a primary key, which is a tuple, you can have a foreign key, which is also a tuple, which can be nice. And by the way, there is many options to under deletion. Usually it's cascade in most systems, but there is many things you can set, like restrict to abort the transaction if the constraint is not satisfied. You can set null, you can set the default value, and so on. Speaking about primary key, actually, at the same thing, it's created index. It's one of the most well-known. Your key can span multiple columns. So if you have a very nice pattern of column you need to have to query your data, put them all in the primary key. Same spirit as some NoSQL databases, but you can do it in Postgres. Actually, there is a custom type which creates a sequence. Everyone know it, which is big serial. But actually, it's not a SQL standard compliant, and Postgres encourages you to use a begin generated always as identity, which is actually the same thing. But one day maybe they will deprecate big serial, and everyone will be we need to upgrade. And yes, it uses an internal sequences. Sequences are like a mutable slot of data you can increase, and they are useful to handling sometimes, as you will see. Yes. Okay. Sorry. When you, just one funny fact, if you want to share a sequence between tables that share the same object, for instance, you have some types. You have a case for your data, and you want to create one table per case because you want to be efficient in your storage. So if you have this, you can create a sequence and then share it using it as a primary key of the other all the sub tables, and then having uniqueness cross table. If you want to check it further, you can use also foreign key relationship where it must be not joining against this key and triggers, but I won't get into it. Basically, the ultimate weapon is in Postgres is triggers, and there is very few use cases to use them, but I don't cover it into this presentation. And well, there is a constraint that is not very well known. You have something in Postgres which is called exclude. An exclude allows you to check against a collection type to ensure there is no overlap. Or than, for instance, a time period is before another time period, or some very range-y, array-y operation. And it's a generalization of unique, and it can span multiple columns. For instance, let's take this table. So we try to construct a maximum of this table. It's a bit of a summary of what we have seen. You have, for instance, resources and users, and they need to rent. User need to rent resources for slot of times, and the slot of times cannot overlap for the same resources and the same user. So actually, what we can modelize thing, we can check that the start time is less than the end time at the table level and not at the column level. And then you can have an exclude using GIST, so it will use a GIST index. GIST is a method of indexing using most of the indices are B trees in Postgres, but you have many way to index data, and it's not covered by this talk. It could be a talk it could be a full talk actually on indexing, but you can using this method of indexing and matching resource with equal, user ID with equal, and then ensuring that the range of start to the end time does not overlap at the same time. So you can, this is code you won't have to check into your application anymore because you express it with 5 lines of codes in your database, and I find it wonderful. And then about abusable data types, it's not the normalization when you have performance problem is not a silver bullet, and can bite you back quite hard. And keep in mind that it's also always a question of time versus size versus speed. If you inline a lot of things in your table, it will become slower. If you use better data structure, it can be faster, but it's always trade-off. And then use all the comment on tricks I show you to document it and enforce the documentation into the database schema to not confuse users. And about a bit of normalization, I explained it a bit when I told you about being tall. Joins are really fast, really fast. What is not fast is reading a lot of buffers from the page pool, which can be solved using a lot of techniques. For instance, cluster that I explained also. So then, let's compose this together. So SQL has a reputation of not being composable. And then people cannot compose SQL does not compose. For me, it's a bit of a rumor. And let's check together all the way you can use to compose a SQL within SQL. Let's take this query. So this query is a medium-sized query, which is not really satisfactory. You have two subselects. By the way, what you want to do, you have employees that have performance rating, and they have projects. And I want to see all the employees that have a good rating, but and involved in more than one project. So we got this into the code base, and this is not what we want. It's too complex. It's not readable, and it can trigger PTSD from a long-term SQL user when you see this kind of thing. Okay, so you have a lot of subselects. Where can we put subselect? And basically, the thing is everywhere. Actually, each clause that need a set of records, like from or wherein, can have a subselect that can return many rows. But actually, you can put a subselect that returns only one row in basically everywhere, in your where, in your join condition, in your select. And it can be, sometimes it's what you want to do, it's what you want to change data. And but often it's very horrible to write because of SQL nature and enforcing of having the clause in the order they have. So let's take this query and let's use something we can, some tricks you can have. Is that we have the two subquery in blue and red, and what we are going to use is to use CTE. So who knows CTE? Okay, so it's pretty common modern knowledge. So CTEs allow us to factorize subqueries. So here I have a third one only to show that they compose together. So you can use old CTE to new CTE, and then suddenly you can read the code. It's in the order you want to present it. It's not the order it will be executed because you delegate it to a database. You release control. But anyway, you can have a much more readable experience using this. And by the way, some fun fact about CTEs. So you can extract logical subqueries. They can be recursive. It's out of the topic for this talk, but you can do graph processing using SQL and with recursive query. And they can produce memoization, which can be a good thing or a bad thing depending on what you want to achieve. But for instance, you can result, it's like the query I showed you in dalibo.com. You can reuse the result of a CTE in other CTE and then use memoization to reduce query time. But sometimes you want to enforce to just replace just copy and paste the subquery in place, and then you can use materialized or not materialized modifier in the after the CTE name. So you can enforce that a CTE is inlined using not materialized. And you can enforce that it is materialized, but I don't see the point of enforcing it. Okay, so sometimes you want to reuse it, cross queries. So what I advise here is to use views that are made to be, actually that are made to do it, to compose query itself. Sometimes we often use views to have an end table to fetch, but actually it can be used just to factorize things at the schema level. So here is the same query actually, and since it's just like a 10-line of SQL code, this is very readable, provided that you documented what is employee performance and project allocation, and cautious is views, so you can introduce subqueries and so on. And this is a part of what you need to introduce as comments. Okay, and by the way, you can, it's a very small thing, but I think some people doesn't know, you can order by tuple, which is very convenient when you want to have like a customizable ascending or descending order. You can just have your tuple and say this two column in descending order. Yeah, so what I said, need to document it. You can do a very nice trick for schema updates using views, since you can separate the representation of your data from what is stored. So don't forget to use it when you do large migration. You can ensure that you have always a table which has a good name, which is queryable. Okay, so let's take back this thing and let's try to think more in a functional manner. This is not really what we want to do. Actually, we are composing two queries, but that are joining together, instead of having a query which is on a table and then joining after something. So let's refactor it this way. So what I did is just I choose a preferred way to query data. Like I take the responsibility to get first to the employee table with some filters, and then I said to the query optimizer, for each row of this select, just do a subselect. And this actually will be translated to a nested loop. And if you have a good join, a good schema with a good relationship in place, it will do the same as having these two subqueries with a join. Trust me, it's like I will use a nested loop join. And from this, you can see that there is a clear function, like you need to take a project ID and get a count, an employee ID, for instance, and get the count of project ID. So how can we reuse this piece of code? How can we factor it? The answer, we are doing we are all functional programmers. Let's do functions. And by the way, they are in your schema, they will be documented, they will be in your migration, so they exist, and you can factorize code using it. And actually, what I do is just, it's like one word. It's just I put a one-liner function. So one-liner, one query function. There is no logic. There is no awful PLP GSQL thing. It's just begin return query. It lacks a query. Your query end, and that's it. And then you have something you can use, which is typed, which can be documented. Actually, you can create a comment on this function, and you can use it this way. And if you need to share sub function in your code base, you can do it using this. We can still do better. What if I want to return not just a project count, but general statistics about my projects? So I won't get in. I don't want to program a get project count, get project mean time, get project count for this category of project, and so on. I want to do it one for all and have it factorized. So how do I return many column from this kind of thing? And there is some neat tricks I wanted to show you using set returning function. Actually, a table in Postgres is a type. It's a product type. And it's very well known. It's the core of the relational algebra, having set of tuples. So you can return it. And we'll see two together. I just won't get in the slide running. Here's the function that returns a table. So it's maybe a bit hairy, so let's just discuss it together. You create a function, you have arguments, you have your project, your column, your table type, which is your return type, and then you begin a return query, and you do your query, the aggregation from employee project, where employee ID equal yada. Nice trick, if you don't know it, you can use a filter in your aggregation, and this will fold in one pass. You won't get all the subqueries as you may have seen. You can just use filter like this. And using this, you will see I compute the statistics, and there you have project stats using employee ID. And then you wonder, how can we have this table run for each row? You need to have something called a lateral join, which can allow you to have join condition depending on like the set or in the join can depend from the current row. And using this, it's like I can have side queries, like I can fetch data from other tables, do my .n relationships and so on, and get it back into my main result set, maybe aggregating and so on. So here I can join lateral, and having all my columns joined into this. Join lateral thingy on true is not very satisfactory, but thanks to Postgres, you can factor it away, because what we want to do is a cross-join between what we get and what the employee table, so you can write it like this, which is pretty neat. So you can use function to fetch data, and if you want to return tables, you can even fetch them, join them all the way, and your join condition, or your join, can depend on the current row. So what I wanted to explain is, maybe it's a bit difficult if you don't manipulate it a lot. But what I wanted to explain is like you have many tools to compose, and to compose it in a very beautiful way, because this is quite concise. Okay, and if you want, the only hard thing is like the lateral term. If you know what lateral things like taking things aside and fetching them back, it's totally what we intend to do. Like take this employee and fetch it project statistics. So you have many tools to compose in SQL. And reduce the noise for large queries. Some queries are still large, because, by the way, if you want to do complex things, it will be complex to write, no magic. But if you want to do a very common thing, reuse parts, have a more concise way, a more relationally thing to write, you can do it. You can put all your abstraction you create in your schema, like you put all your abstraction you create in your code. Let's play with your SQL schema. It's not like a religiously kept vault where you never move. It's something that can be dynamic. You can do migration and so on. And with good tooling, it's bearable. It's just that we are not used to use tooling for SQL. Tooling for a programming language is very well developed. You have LLM, you have a language server, you have a lot of things, completion, and so on. For SQL, it's not the same level, and it's a shame, I think. And then be relentlessly uncompromising with your queries. Like, don't be satisfied with quick and dirty work. Usually, when you write Scala code, you're not satisfied when it's not not perfect, but at least bearable for someone to read and so on. And I think a lot when I began writing SQL, like large queries, I was very dirty, and I put if it works, it works. And then you have just read-only code, and read-only code with SQL tricks and so on. It's not something you want to have in your company, because it's not something that scales. So that I wanted to say about SQL. By the way, this I want to do it because I think I don't have the time. But by the way, you can do your. It was just about having the 1 to n relationships. If you have an article, you want to have all the comments for the article. You can do it in one query using a set returning function and a JSON BAG, for instance. And so you can fetch data and all the data, the side data in a JSON array. That's why JSON is very easy to. It's very interesting to use actually in Postgres because it allows you to have complex columns that came back to your application, and then to only do one fetch in database instead of two or n+1 if you're not cautious enough. So first, this is the opinionated part about what is a backend system. So when you modelize data, there is business logic because you have your domain model, you have your constraints, you put into your database. When you choose the data types, and you choose to put business logic into it. So you already have business logic in your database. Just a matter of where do you draw the line. Do you have a very dumb model, so it will be a very dumb representation of your domain model in the database, or do you constrain it a lot and use functions, SQL functions and so on, to put a lot of work on the database side? It's a line you need to draw. It depends on your use case, actually. Sometimes a dumb model is better, sometimes a very complex model is better. But anyway, if you choose to modelize things, you put business logic into it. Database is often, since cloud computing and since the introduction of ORM, it's seen as an external tool, not a platform. It is a platform. Postgres is a platform. You can do a lot of things. Some people are building web server on Postgres. I won't recommend it, but you can do a lot of things. And it's a very powerful platform to manipulate data and tables and relational data. You have to reclaim it. And that's why Scala is very important for this to me, because it's the best lingua franca you can have to stitch things together between databases, external services, providers, and having a good HTTP interface or whatever you use. Scala is awesome because you can modelize things quite nicely. You can even put constraints into type. You can do a lot of type level stuff to ensure correctness and match the correctness of your database. So to me, we need to be aware that the software world is just databases that talk to each other, and using Scala is making glue between databases, and that's the message I wanted to show you today. Thank you. Are there any questions?
Thank you, Valentin.